Okay, ladies and gentlemen, we're going to continue our walk deeper into the woods when we're dealing with exponents and powers and all that good stuff. Today, what we're going to be learning about are our power of a product rule and also our power of a quotient rule. Okay, so every other property that we've dealt with up to this point is still going to apply. We still have the zero property, so anything to the zero is raised to the one power. Our negative property, so any exponent that's raised to a negative power, we now know that we need to move it from one side of the fraction to the other. So if it's in the top, we have to move it to the bottom, and then it becomes positive. Again, it has its ticket to ride, and once it goes on its ride, it no longer has a ticket anymore. I like to think of it like that. Or if it's a negative exponent at the bottom, we move it to the top, and it becomes positive. So that's our negative property rule. We have our multiply powers. So the quick shortcut here is we would keep the base x, and we can add those exponents. So ultimately, we are multiplying 3x's to 5x's. Altogether, that would be 8x's. And then we have the dividing powers rule, where we have, if we have a common base that we are dividing, or common power that we are dividing, what we can do is we can subtract those exponents to find out what our simplified version would be. And then here, if you just take a step back and look, we have more x's down at the bottom than we do at the top. We have two more x's, more specifically on the bottom. So we can write that as 1 over x squared. Again, the shortcut would be 3 minus 5 gives us x to the negative 2. And of course, we can't have negative exponents in our answer, so we move that guy downstairs. So no matter which way you go about thinking about it, we want to make sure that you have the right particular solution direction. So here, this is our product of a power rule. So whenever we have a product, okay, in other words, a term that have a bunch of multiplication inside of it, and it's raised to a power, we have to distribute that power. So this is also a distribution of powers that can also be considered, because it's going to work for our product and also for our quotient down here. It's going to be the same thing. So we are going to distribute this exponent to each of those things and each of those bases inside the parentheses. So what does that look like? Well, we can think about expanding this. So what we really have is this quantity 3x, and it's multiplied to itself. So when we multiply it to itself, I mean, you could see it very clearly what happens here. We have 3 times 3, that gives us 9, and we have x times x gives us x squared. Okay, what's our shortcut? Well, I could assign each of these exponents a value of 1, and then I can distribute this to, remember, whenever we distribute, we always multiply. So that would leave us with 3 squared times x squared. All I did is did 2 times 1, 2 times 1, and that simplifies to 9x squared. This guy here, you can see that we have the quantity negative 3 raised to the second power. That means we are multiplying negative 3 times itself twice, and negative times negative gives us positive. 3 times 3 gives us 9. Okay, there's really only one exponent here, but the thing we have to keep in mind here is that we have a negative that we are multiplying to itself. So, that negative 1 also is affected by this square here, this power of 2 that it's raised to. So we need to make sure that we're multiplying that negative times negative to give us a positive 9 here. Again, we could type this right into your calculator, but if the problem gives you parentheses, make sure that you're typing parentheses into your calculators as well. All right, so we have here 5x to the 6th raised to the 2nd. So we have 5x to the 6th times 5x to the 6th. What we have here is 5 times 5 gives us 25. And then we have x to the 6th times x to the 6th. So remember our multiply powers rule. The rule is we can keep the base, and we can add these exponents. 6 plus 6 gives us 12. All right, so that's what our answer turns out to be. What does the shortcut look like? Well, I could take my, we see that we have an exponent here of 6, but for the 5, we really have an exponent of 1. We can't forget about that. So I need to distribute this 2 to each of those bases, each of those powers, I should say. So this becomes 1 times 2 is 5 to the 2nd. And for the x, we have 6 times 2 gives us x to the 12th. And again, that simplifies to 25 x to the 12th. Last couple problems here. You can see how this can kind of get a little kooky. We have 3 squared times 3 squared. That really gives us 3 to the 4th. Okay, again, I kept the base and I added those exponents. again, I just expanded this base raised to this exponent here. So I just repeated what we are multiplying to itself. That's how I expanded that out, but I'll do the shortcut momentarily. We have x to the negative 6 times x to the negative 6. We keep the base, add those exponents, so we get x to the negative 12th. And then finally, we have y, that is y to the 8th times y to the 8th. Add those exponents, we get y to the 16th. Now, we know we cannot keep our answer like this because we have negative exponents. And really, it's good to simplify the 3 to the 4th, which is 3 times 3, which is 9. 3 times 3 is another 9. And 9 times 9 would give us 81. So I'm going to put my 81 here. I know that I got to move this guy downstairs, so I'm going to make a little line here. I'm just going to write my x to the 12th. Once it moves downstairs, it's now positive. And this y to the 16th can stay upstairs with the 81. And that would be our final answer right here. What does that look like if we were to expand everything out? Or if we were to do our quick shortcut rule? Well, if I distribute this 2 to each of those exponents, we end up getting 3 to the 4th, just like what we did above. Negative 6 times 2 gives us x to the negative 12th, just like what we did before. And then also we have 8 times 2 gives us y to the 16th. All we have to do at this point then is make sure we get rid of our negative exponents, simplify our 3 to the 4th, our y to the 16th stays put, and there we have it. Moving on to the next one. We can distribute and expand, I should say. So we have the common base of a that we are multiplying to itself. So we add these exponents. 3 plus 3 gives us a to the 6th. Same thing for the x. 3 plus 3 gives us x to the 6th. And that's as far as we can go. The shortcut is I could multiply the 2 to each of those 3 exponents, and that will give us the same thing that we have here. Over here, I will scroll this down. What I did is I got rid of the negative 2x1. Now I could have distributed, and I'll show you what that looks like. But what I did is to expand this out, because this is a negative exponent, it really means that we have to move all this stuff down at the bottom. Okay. For this particular problem, it's probably easier to distribute this exponent to each of those other exponents inside the parentheses. So what does that look like? Well, doing it the long way, if you will, we have a common base in the bottom of x, and we can add those exponents. It gives us x to the 6th. And then we have a common base of z down at the bottom that we would add these exponents, and you end up getting negative 14. And whenever you see a negative exponent, I hope it rings some bells in your mind saying, "Eek, can't have it." So we got to move that upstairs. So our final answer here is going to be z to the 14th all over x to the 6th. And there are no negative exponents there. There's no zero exponents there. We are all good. Again, the shortcut here would have been to distribute and multiply the exponents here. So 3 times negative 2 gives us x to the negative 6th. Over here, then we have z. Negative 7 times negative 2 gives us z to the positive 14. Okay, so if you look closely here, we know that we have to move the x downstairs. The z would stay upstairs, and we end up getting the same thing that we had down here. Okay, so that's our power to a product rule. We also have a power to a quotient rule, which is the same kind of thing. We're just distributing those exponents, okay, by multiplication. So 1 times a gives us x to the a in the numerator. 1 times a gives us y to the a in the denominator, okay? And so it's the same kind of thing. I can distribute or I can expand. And so in this case, I expanded here, which gives us, you could obviously see we have the quantity 3 divided by y that we're going to multiply to itself 2 times. 3 times 3 on the top gives us 9. Y times y on the bottom gives us y squared. And that's as far as we can go. It's cool. The quick shortcut is each of these gets a little 1. If there's no exponents there, we know it to be a 1. And I'm going to distribute that to each of those exponents. So we have 1 times 2 gives us 3 to the 2nd. 1 times 2 gives us y to the 2nd. And that would simplify to what we have over here. Moving on to number 8. Same kind of deal. This is kind of like almost like the same rule that we have up here. Each of these gets a 1. You can expand it out, whatever you want to do. This is pretty straightforward. We end up with u squared over k squared. Distributing the 2 here obviously gives us exactly that. All right, moving right along, distributing and or expanding. I expanded here, and you can easily see that we have 5 times 5 on the top gives us 25. We have x to the 6 times x to the 6. When we expand that out, or when we multiply that base that many times, we end up getting x to the 12th. And then on the bottom, we have y times y gives us y to the 2nd. The quick shortcut rule here, a lot of people forget about the 5. They forget to put the 1 out there, but we can't forget that the 5 is also being multiplied to itself 2 times. All right, so when we distribute all together, we end up getting 5 squared. We get the x, 6 times 2 gives us x 12th. And then y to the 1 times 2 gives us y squared. And that simplifies to what we had earlier. Finishing up here, we have this big, huge, messy thing inside here with negative exponents raised to the 2nd power, so you could distribute through. What that would give us is y to the negative 12, or excuse me, x to the negative 12th, because negative 6 plus negative 6 gives us negative 12. For the y's, we have 8 plus 8 gives us 16. And then for the z's, we have 2 plus 2 gives us z to the 4th. But we know we cannot end like this because we have the negative exponent here that we know needs to go downstairs. So our final answer is actually going to be y to the 16th. And I'm going to put this in alpha order, x to the 12th, because once it moves downstairs, it no longer has the negative exponents. And then the z to the 4th would be there. So that would be our answer. What I could have done is the quick shortcut, distribute that exponent to each of those powers, and then you could see it kind of happen. It kind of unfolds quickly. X to the negative 12th, y to the 16th, all over. 2 times 2 gives us z to the 4. And again, that simplifies to what we have down here because we have to move this x to the negative 12th downstairs as well. Last 2 problems here. Distribution. I'll do the quick distribution shortcut. It goes so much faster. All right, so what we have here is we have a, 3 times 2 gives us a to the 6th. 3 times 2 again gives us x to the 6th. And then down here, we really have a 1 here, so we have to make sure we're mindful of that. 4 to the 1st times 4 to the 1st gives us 4 to the 2nd, in essence. 1 times 2 gives us 2. And we can simplify the bottom, the denominator there, a to the 6th times x to the 6th. And then, of course, 4 squared is 16. 4 times 4. Again, the quick shortcut here, this would lead us right to this. A to the 3rd times a to the 3rd is a to the 6th. X to the 3rd times x to the 3rd. We add those exponents, we get x to the 6th. 4 times 4 gives us 16. And our last problem here, again, if you expand this out, you can kind of see that we really have a negative times a negative, which is ultimately going to give us a positive here. If we're multiplying a common base, we can add these exponents. So that would leave us with positive x to the 6th. And on the bottom, again, we would add those exponents. That would give us z to the negative 14th. And of course, we can't leave our answer like this. We got to bring this guy upstairs. So what we're left with here is x to the 6th times z to the 14th, all in the numerator. I could put it all over 1, but I'll just leave it just like this. Again, the shortcut would be to distribute, and then also being mindful of this negative here. So this is really like negative 1 times negative 1. I'm going to put that here like this. On the top, we could multiply these two guys, so that gives us x to the 6th. And on the bottom, we end up having to multiply that as well, so we get negative 7 times 2 gives us negative 14. And then you can kind of see what happens here. This negative 14 has to come up. Negative 1 squared is really negative 1 times negative 1. It becomes positive 1, which I could have threw that 1 out here. Regardless, doesn't matter. It's still going to give us this final answer of x to the 6th, z to the 14th, all over 1, or just x to the 6th times z to the 14th. Those examples, you can rewind, you can check it out. Look at those again. There's practice problems coming at you, and I hope you have a wonderful time doing them. If you have any questions, email me or send me a message through Google Classroom. Have a great one.